So this question's a little bit of a tricky one. It's a conceptual one. We have to choose which of the following, or when we apply the conservation of energy principle to a cylinder rolling down an incline without sliding, we exclude the work done by friction because, so we have object rotating, there's some friction on the surface, it's rolling down some incline with some angle theta, some moment of inertia, some mass, some radius. Why do we not include the work done by friction? Well, in order for this thing to start rolling, there would have to be friction present. Just the thing would slide otherwise. There would be no way to institute a torque on this. It would be very difficult for this thing to start to spin. It could potentially just slide down. So friction is going to keep this thing point. What we're going to look at is every point, when it attaches to it, that point does not slide. It rolls without sliding. So these points, that point on the bottom of the circle and the point on the surface of that ramp, never slide along each other. They're stuck to each other for a brief moment. So that actually is the way that we're going to solve this problem. So there is friction. Coefficient of static friction and kinetic friction are equal. That just doesn't really actually make any sense. Coefficient of kinetic friction is 0. We're not actually in a kinetic friction. We're actually in a static friction state. So it doesn't matter what the kinetic friction is, and it's not because it's 0. The angular velocity of the center mass about the point of contact is 0, or the linear velocity at the point of contact relative to the inclined surface is 0. The correct answer is D. And that's what we were saying, is we're saying that this point right here does not slide. So the force of friction acts at that point right there, but it does not have any distance that it's moving, right? We know that the work done by this friction will be F dotted into D. The force of friction times the dot product, actually, of the displacement vector, where D is how far that point slides. Well, that point does not slide. That is a zero slide. Even though the whole thing moves, because it rotates, this point does not slide. The center point moves, the top point moves, but the bottom point is always going to be in contact with the ramp and not sliding along the ramp.